Okay, the last problem in the problem set, the group problem set. Uh, this was probably the hardest problem. I helped you out a little bit by doing some color coordinating here. We have to make this big molecule. Look at this. We have to make it from benzene and anything with 4 or fewer carbons. So again, look at this. We have to make a bicyclic ring system. That's a lot of carbon-carbon bonds we have to form. That's going to be difficult. We have to make this ester. That's not going to be so hard. We know how to make esters. We're going to have to install some things on benzene to get it in the right position. And the same over here. We're going to also have to get this benzene ring and add it. So let's think about this synthesis problem. Let's break it down, do a retrosynthetic analysis. So the first thing, I gave you some color coordination, hoping that you would see that what we want to do is break this apart into some more manageable pieces. This ester formation, that's easy. We can make the acid chloride. We see that we have a 6-membered ring here, and it turns out to be an alkene. So we could install that through a Diels-Alder reaction. So we break this apart. Now we just have to make these two pieces. It looks pretty easy to make. We're restricted by some of the chemistry we learned, so it's going to be a little more difficult for us than it might be otherwise. And this is the other thing we have to make, and hopefully this isn't too daunting. We see that we're going to do a series of aldol types of condensations, Robinson annulation type of reactions. So we can break this down. Remember, if we just think about this as a kind of a Robinson annulation, and think about that as being acetone, that would be the nucleophilic carbon, this one. So we can break it down into these two pieces. And this is an alpha beta unsaturated compound. We made those through aldol condensation type of chemistry, where we would have acetone as our nucleophile and benzaldehyde as our electrophile. So once we learn that, a retrosynthetic analysis, we don't have to do every single step backwards. We just have to break it up into manageable pieces. And we want to look at the easy chemistry first, because when we're doing a great big molecule, we want our last steps to be high yield, easy types of reactions, if we possibly can. So an esterification is pretty easy. We can make that on the side. Diels-Alder reactions will go pretty well. It might be nice if there were some other things on this. This is a gaseous molecule, but we can go ahead and do this Diels-Alder chemistry. We then have to make this compound, and hopefully we quickly see that we have an alpha-beta unsaturated compound. We can break it into an aldol type of condensation reaction. This is a special kind of the Robinson annulation reaction, and we can make that, again, an alpha-beta unsaturated compound through an aldol condensation. So let's now start at the beginning and go ahead and do our first step. Our first step, we have to make this molecule. It turns out this may be a little bit more difficult than we thought. So we could make this, install this first, and then do a formylation reaction. There's reactions that will put a formal group on there. We just didn't happen to learn any. So we had to be a little bit more tricky. So what we decide is we're going to make a carboxylic acid. So we can start off by doing any alkylation or acylation reaction. So long as we have a handle on the benzylic carbon, we can then oxidize it to get benzoic acid. We can then turn the benzoic acid into an ester or an acid chloride and treat it with diol, and we end up getting this benzaldehyde. Now you're going to wonder, how do we get the ethyl group in the para position? Because this is first of all, it's a meta director, and second of all, it deactivates the ring, so we can't really do Friedel-Crafts chemistry. But we can be a little bit cagey here, and what we do is we protect the carbonyl with ethylene glycol. We make the cyclic ester as the protecting group. That reverses the directionality. It actually makes it very slightly electron donating, and it's an ortho para director. Not only that, it bulks up here, so it takes the ortho positions a little bit more out of play because there's a lot of steric hindrance there. So when we ethylate it with ethyl bromide or ethyl chloride, we would probably use the bromide because it's low boiling liquid. If we use the ethyl chloride, that's a gas, so it's a little bit harder to do. So it would be easier to use the ethyl bromide and just do electrophilic aromatic substitution reaction. We would use Lewis acid catalyst, and then we would deprotect our aldehyde and end up getting this piece of the puzzle. Okay, so a little bit tricky there. We can then react this with acetone. The KOH will pull off a proton here, turn this into a nucleophile. It'll attack the benzaldehyde carbon, and we're going to end up going all the way to condensation. We actually have difficulty isolating the aldol addition product. These go right to the aldol condensation product. So that was the piece of the puzzle that we needed here. We then just have to repeat that step in a different fashion. We're going to go ahead and do another aldol condensation reaction, and this will attach at the carbon, make our 1,5-diketone, which we can then push. We're under basic conditions. That 1,5-diketone can go all the way to the cyclic compound. Here we go. We can do that. Okay. The next step of the reaction, we just do a Diels-Alder reaction. We do a Diels-Alder reaction here. We go ahead and do our Diels-Alder reaction. We get this piece of the puzzle. Now we just have to clip these two things together. We can reduce the ketone to get to the alcohol, and the last step in the reaction is relatively easy. All we have to do is clip that together in some sort of esterification reaction. We take the carboxylic acid that we make by gentle oxidation of our benzaldehyde. So we can't use KMnO4 because that would oxidize both to the carboxylic acid. We just want to oxidize one to the carboxylic acid. So we're going to use something relatively gentle. Once we make that, we can either go ahead and do the Fischer esterification, or we could convert this to the acyl chloride by reacting with thionyl chloride. But these are relatively easy to do, and we get our final product. And that's it for today.